Okay, so we're going to graph linear functions today. So you're going to need that sheet of graph paper I gave you, and I didn't think about this at the time, but if you want a straight edge or a ruler, I do have rulers in the back, and once we get there, which will be the second example, we can get those out. Or you can use the calculator cover. Actually works as a pretty good straight edge also. You could use that for a straight edge, but if you want a ruler, then I'll pull them out in a few minutes. Okay? All right, so meteorologists begin tracking hurricane distance from land when it's 350 miles off the coast of Florida, moving steadily inland. The meteorologists are interested in the rate at which the hurricane is approaching land. Now, we've had a couple big ones lately, haven't we? Unfortunately, the one that hit Nepal was, that was an earthquake, not a hurricane, but we have had some of them recent that are pretty destructive. So we need to be careful of them. And so this is very important that they can judge how soon it's going to hit to help people to figure it out. Well, quite often the movement of the hurricane, because they move at a steady rate, is a linear model. Right? So basically like a sequence where the numbers are changing at the same amount each time. And so when we look at them, we look at the change in the distance divided by the change in time gives us the rate that they are moving. And the rate is actually what we would call a slope for our linear functions. So most linear functions, when we're going to be working with them, we're going to work with them in this form here. F of x equals mx plus b, or y equals mx plus b, where m stands for the slope of the line, and b represents the y-intercept. Okay? B is the y-intercept, which is the constant, and m is the slope, tells us the rate of change, how much it changes each time. So first of all, if something is linear, that means that the y values have to change at the same amount each time. And so to determine whether a data set could represent a linear function, two things have to happen. First of all, the x values have to change at a constant rate, and the y values have to change at a constant rate. So the first thing we're going to look at is a set of data and try to determine whether that could represent a linear function or not. So when you look at the x values here, -2, 0, 2, and 4, okay, do they change at the same amount each time? Okay. And there's a way to figure that out. We subtract. We take the next number and subtract the previous number. All right? And we do it for all of them. So we do it here, and we'll get there's a change in 2 each time. 0 minus -2 is 2. 2 minus 0 is 2. 4 minus 2 is 2. So as long as since the x values are changing at the same rate, okay, we're good so far. Now we have to look at the y values and see if they change at the same rate. Okay. And most of the time you can look at them and just see it. Okay. So what's happening with the y values in this case? Okay, all right, they're going down by 1 each time. And when we start dealing with and talking more about slope, that this is linear because both the x and y's change at a constant rate, and our slope then for this situation would be -1/2. How much y changes divided by how much x changes. Rate of change in f of x or change in y values divided by the change in the x values. So since that provides us with -1/2, then it is linear. All right, so first we look at the x values. Here we have 2, 3, 4, and 5. Okay. All right, so each of those goes up by 1. So we're good there. Those change at a constant rate. We look at the values of f of x. 2, 4, 8, and 16. So do those go up by a constant rate? Let's see, this is 2. 8 minus 4 is 4, so I'm done since those two aren't the same. So this could not represent a linear function or a linear model. What kind of a model is that? Anybody know? Okay. This would be an exponential model because they are doubling each time. Okay. It's called exponential. All right, so how about these two? Okay. All right, the constant rate of change for a linear function is its slope. Slope of the linear function is the ratio, change of f of x over change in x, or what we call, and you guys have probably talked about it before, rise over run in your previous classes. Slope of the line is the same between any 2 points on the line. You can graph lines by using the slope and a point. All right. So here, they give us the slope of 5 over 2 that passes through the point -1, -3. Now this helps us from what we did in chapter 1 with the transformations, because we're basically going to do a transformation here. We're going to start at the point -1, -3. We're going to go up 5, and we're going to go to the right 2, okay? Which is something you did on the test on Friday, is you had a point, and you had to do something similar to that, find the next point. Now, when we find the next point, Avery, now we can draw that line through those 2 points, okay? All right, this is the case where we're supposed to do that. All right, so I find my point, -1, -3. Put a dot there. Find my other point. So I'm going to rise 5 and run 2. All right, and we always rise and then run. So we rise up and we run to the right. Okay, rise up and run to the right. So from that point, we're going to go up 5 to 2 and over 2 to +1, then draw our line through that point, those 2 points. All right, and don't forget what? Arrows. Okay, if you do not have arrows, it is not correct. So make sure you put arrows on the end of your lines. Find the point, go up 5 and over 2. Now, what if the slope is negative? Does the negative go to both of them? No, if it did, it'd be positive, right? Okay. So we always, whenever we have a negative slope, the negative always goes with the numerator. So we always run to the right, but if it's negative, we're going to fall instead of rise. Okay? So we have the point 0, 2. So then we're going to go down 3. 1, 2, 3, down to -1, and then 4 to the right. We'll put our point there. and draw our line. And put arrows on the ends. Don't you wish you had that on your paper?
Yeah.
Boom, boom, and hit a button and the line draws.
No, that's the lazy way.
That's the lazy way.
Yeah.
All right. Okay, how many of you remembered that before I reminded you? Okay, excellent. That's good. That's good. All right. Okay, rise over run. All right, so we are actually going to look at 3 different graphing methods today. We just looked at one. Give you a point. Take the slope. Graph those 2 points, draw the line. Okay. Now we're going to look at what's called the intercepts. Okay. We have the y-intercept, which is where the graph crosses the y-axis, and the x-intercept, where the graph crosses the x-axis. Now, there's some specific things that happen when they cross the x and y-axis. Right? When the line crosses the x-axis, y is equal to what? 0. And when it crosses the y-axis, then x is equal to 0. Okay? So we cross the x-axis, y is 0. Across the y-axis, x is 0. So when we find the intercepts, what we're going to do is put in 0 for x, 0 for y, and find those 2 points and graph them. All right, so here we have the line 4x minus 2y equals 16. Now this line is in what's called standard, pretty much standard form. There's a general form, which in a general form it's always equal to 0. And this is a standard form. And then in the next example, we're going to look at slope-intercept form, which is something that you've seen a lot and hopefully worked with a lot. Okay? So first we're going to find the intercepts. So we're going to find the x-intercept first, which means that y equals 0. Okay? So I'm going to put 0 in for y. So 4x minus 2 times 0 equals 16. So what do I get when I multiply by 0? 0. So the nice thing about this is that part's always going to be equal to 0. So we get 4x equals 16. So x is equal to 4. All right, so there's my x-intercept at 4. All right, so I'll put a dot on the x-axis at positive 4. Okay, then we want to find the y-intercept. And for the y-intercept, that means that x equals 0. So we have 4 times 0 minus 2y equals 16. So 4 times 0 is, so we got negative 2y equals 16. Divide by negative 2, and y equals negative 8. Just my graph. So that means I put a dot on the y-axis at negative 8. Okay. So how many points do I have now? Okay, 2, and that's how many I need to be able to draw a straight line. So to find the x-intercept, we let y equal 0. To find the y-intercept, we let x equal 0. Plot those two numbers and draw our line. Okay, here's a little caution. Remember, the intercepts are a single value, not an ordered pair. So when you write the intercept, it's just either x equals or y equals. It's not a point 0, 2 or the point, or 0, -8 or 4, 0. Okay, so that's one method of graphing, is by finding the intercepts. The other method is by getting the function in slope-intercept form. Okay? In slope-intercept form is very important, and so you need to make sure you're familiar with it, because there's lots of times where you're going to be asked to write the equation in slope-intercept form. So that means we have to solve for y. So those two warm-up problems that we did with solving for y, it was a reason, because we're going to do that. Okay? And then once we solve for y, we now have in slope-intercept form, it tells us the y-intercept. Hey, there's a point. Okay? And it tells us the slope, so we can rise and run to get to our second point. So here we've got negative 4x plus y equals negative 1. And they want us to get this into slope-intercept form. So we're going to solve for y, which means I need to get, if x is on the same side as y, I need to move it to the other side first. So we're going to add 4x to both sides first. Now, here's the thing, all right? When we're doing slope-intercept form, the part with the x comes first. So make sure you write that part first. So instead of saying negative 1 plus 4x, write it as 4x minus 1. So we have b is negative 1. That's our y-intercept. And m is 4, and that's the slope. Now, the only thing is, the slope has to be a fraction because we have to rise and then run. Okay? Well, this isn't a fraction. So how can I write 4 as a fraction? Okay, 4 over 1. So whenever it's a whole number, it's that number over 1 for my slope. So I'm going to rise 4 and run 1. So I mark my y-intercept of negative 1. And then from there, okay, from that point, we're going to go up 4 and over 1. That would be our next point. And then we'll draw our line through there. And so if you want to put dotted lines to show your slope, that you went up that far and went that far, okay, that's fine. But we have to make sure it's a fraction, and if it's a whole number, then you just put it over 1. All right, here we have x plus 3/4 y equals 6. So first we've got to get it into slope-intercept form. So we want to get the part with the y by itself first. So what do I do first, Cole? You want to put all that on the other side, or you want to get rid of? Good. All right, so we're going to subtract x first. So 3/4 y equals negative x plus 6. Okay, I'm going to write it with the x first. All right. Now, to get rid of the 3/4, okay, normally we would divide by that, right? Because we're multiplying times y. But if it's a fraction, we're going to multiply by the reciprocal. So we're going to multiply this whole side by 4/3. Okay. Dividing by a fraction is the same as multiplying by the reciprocal. So we're going to do that because now on the left side, we get 4 times 3 in the numerator, 3 times 4 in the denominator. So those are both the same. So we're left with just y equals negative 4/3 x plus, what's 6 times 4/3? 8. Okay. 6 times 4 is 24, and 24 divided by 3 is 8. So we get in slope-intercept form. So now we know that b is 8, the y-intercept, and m is negative 4/3, our slope. So sometimes you have to make a little bit bigger window to do this. All right? Or adjust it. Maybe you're not always going to be in the middle. Okay? Maybe your axis isn't always going to be in the middle. So it's always important to find these things before you actually make the graph that you're going to, okay, the axis that you're going to graph on. You've always got to have, so you can see both of them, okay? But you don't have to always be equal all directions, okay? Make sure you understand that. You could make one like this, or smaller, instead of just go to like negative 4 and 4 if you need to. So y-intercept is 8. Slope is negative 4/3, so we go down 4 and to the right 3. So from 8 down to 4 and over 3. There's our second point, and we draw our line. Okay. All right, so the hardest part about this is getting it from into the slope-intercept form sometimes, but move the x and divide by the coefficient of y. Now sometimes when you do it, you may end up with let's look at 4b here for a second. We're just going to get it in slope-intercept form. Okay, the part B here, and then check it out. I think you guys are all expert graphers, right? But I want to look at this one because actually I want you to do it. Just do letter B here. Get it in slope-intercept form. Okay. So make sure in that situation, whenever there's a coefficient of y has a coefficient, we divide by both parts, okay, separated into 2 pieces. Okay. Okay, last thing. Horizontal and vertical lines. Vertical lines, slope is undefined, there is no slope. Horizontal lines have a slope of 0. Okay. Vertical lines are x equals. Horizontal lines are y equals. All right, so for some of you, you're going to have to think backwards. Okay? Horizontal is y equals. Vertical is x equals. Now here's the way I look at it. If it says x equals 5, that means that when x equals 5 and y could be any number, okay? It could be 5, 1, 5, 2, 5, 3, 5, 4. So I just think about that, and that means I'm going up. And so that means I draw a vertical line. Okay? If it's y equals, the y value stays the same, so I could have different x values. Okay? So here we have letter A, x equals 2. Okay? So when x equals 2, that means that, x equals 2. So it could be a 2 there. It could be, it's 2 there. It's 2 here. It's 2 here. 2 there. 2 there. It's 2 down here. Okay? All right. That's a vertical line where x equals 2. Okay. So I draw vertical line. Says y equals -4. So it's -4 here, and it's -4 there, and it's -4 here, and -4 over here. So those are make a horizontal line. So we've got x equals 2 is vertical. Y equals -4 is horizontal. Okay, so a lot of people want to think when they see x, they want to draw a horizontal line. When they see y, they want to do a vertical line. Okay, but it's just the opposite of that. Okay. All right.